Okay, so we are busy discussing circuits and we are looking currently at parallel circuits. Okay, so we saw that with parallel circuits, the current, the little men that walks, they split up. They can choose where they want to go to, but the number of sandwiches, the volts in parallel are the same. That's what we looked at the previous time. Okay, so they said there that we have a circuit, a parallel circuit like that. The number of sandwiches or the volts are 6 volts. Here you have an ammeter. An ammeter measures the current, and because the whole current must pass through there, it measures the total current. Then the current splits up into 1, 2, 3. The first branch has a 2 ohm resistor. The second one has 2 6 ohm resistance. So together that gives you 12. And the third branch has a 4 ohm resistor. Because they are in parallel, each branch gets 6 volts, 6 volts, 6 volts. Okay, so because the total volts is 6, then each branch gets 6 volts. Alright. Okay, so it asks there, calculate the reading on the ammeter. The ammeter measures the total current, so we want the total current. For that we need the total volts, which is 6, and the total resistance we calculated using the parallel resistance formula. Just sanitize, please. Okay? So we said we use that formula. That will be on your data sheet. So you're going to use that formula. So we say 1 over 2 plus 1 over 12 plus 1 over 4. That's what we did there. So we calculated 1 over R parallel, but we don't want that. We want R parallel, so we swap them around. 12 over 10, so we swap them. And that is 1.2 ohms. Okay, now, 2 things regarding 1.2 ohms. Okay, number 1 is you must always show that step where you swap them around. You must show up until matric. Show this step. Okay, so very important. Up until matric, you must show that step. If you skip, if you don't write equals that, then you lose a mark. Then the next thing, how do you know that you did it correctly? How do you know that this answer is correct? 1.2. That 1.2 must always be smaller than your smallest one in parallel. So is 1.2 smaller than 2? Yes, it is. So that is how you know you're more or less on the correct path. Okay. So our total resistance is 1.2. Then we are going to write R is V over I. Okay, now those that have all their notes there, if you look at the data sheet that I handed out at the beginning of the year. If you have it here, please open there. Anthony, can I just quickly get yours? Okay, so at the beginning of the year, I handed out data sheets somewhere. Right. So there you can see the data sheet. You'll always get in the test or an exam. If you need it, you'll get it. Okay, so like in this test, you got the periodic table because you needed it. So in the next test, you will probably need some of these formulas and you'll get it in a test. So at the bottom there you can see is a table that says circuit, electric circuit, and there's the formulas that you will get. Okay, right. Now, another formula that I'll put on there for you for a test or an exam, thank you, is this formula right here. Okay, so you will write it down exactly like that. Then you substitute your values. Our resistance we calculated as 1.2. The volt is 6 and we want the current. Okay, now Bungani. That I is at the bottom of it. Do you like it if it's at the bottom? No. What are we going to do to get it at the top? Okay, what do you mean with swap? Okay, you know, swap is fine, but like, what do you mean with swap? Okay, but if you do that, remember what you do on the one side, you must do on the other side. So if you say I over 6, then you must say 1 over 1.2. No, what you do on the one side, you must do on the other side. Okay, this. But now we still want I Bongani. I is at the top. It's fine, we're happy. How are we going to get I on its own? By? Yeah, I is now at the top. We're happy there. But it's attached to something else. How do we get rid of that something else? With what? You want to call someone?
Yes, ma'am.
Who are you calling? Kaiser? Yeah. The question is, we must calculate I. I is at the top, we're happy like that. But it's attached to the 6. I want to get I is equal to blah, blah, blah. How am I going to get rid of that 6? It's currently you're dividing. If you want to get rid of it, you must do the opposite. You times by 6. What you do on the one side, you must do on the other side. So we have I is equal to, so I'm just swapping them around, 6 times 1 over 1.2. Can you see that? This cancelled out. Let's take it to the other side. And if you calculate that, what do you get underneath? Hey, kom. You don't have all that. Ja, pakkies. What do you get? 5. 5 what? 5, I want the unit. Okay, I want the unit. What do I write down there? Is it ohms? Is it volts? Is it amperes? Huh? For current. Page back in your notes. What do we measure current in? Yeah, don't listen to Mosi. Page back. We want current. I. What do I measure I in? Everyone page back. If you don't know, you page. What? See it? What did you say? Huh? I can't hear. Next page. Next page. There. I. What do we measure I in? In the middle of the page at the block. Amperes. Hey. Right. Okay. So what did we calculate there? We calculated that reading there will read 5. It will be 5 amperes on that ammeter there at the top. Okay? Right. Now they want the current in each branch. So we say, right, we have 5 men going there. 5 men. We want to know how many go through there, how many go through there, how many go through there. So we're going to look at each branch separately. Okay, so let's first look at the 2 ohm branch. Okay, so I'm looking at that branch there. We want the current, that is the question. The resistance for the 2 ohm branch is 2 ohms. Mosi, what will the volts be for this 2 ohm branch? 6 volts. Okay. Now I'm going to rearrange the equation. Don't do that in a test exam, but just so that we can go quicker. V is volts over resistance. The volts is 6. The resistance is 2. So we get 3. What, Mosi? Okay, so we see now that of the 5 men that walks there, 3 of them go through there. So most of them go through the 2 ohm resistor. Does that make sense to you, Botsebo? I'll repeat again. This ammeter reading says 5 amperes. Then the number of the 5 here, 3 goes in there. So we have 2 left for there and there. Does it make sense to you that most of the current, the biggest part of the current, goes through the 2 ohm resistor?
No.
Why not?
Because
Who are you calling? Princess, why? Does it make sense? It does make sense that the biggest part of the current goes through the 2 ohm resistor. Say again? You guys are fast asleep. Yes, Bongani, please.
Because it's closest to the data.
No, Mama. Yes, because it's the smallest resistance, it's the easiest to go through, so most of them go through there. The more difficult it is, the less charge or electrons or mean goes through there. It's like in life. If it's easy, most people go through there. If it's difficult, the least amount of people go through there. Ne? Yes. Not? Okay, right. So the next one, so we looked at the 2 ohm resistor. Now we want to look at the 12 ohm resistor. Because they are for each branch. So we must look at each one. So the resistance is 12. The volts will be what? Botsebo? For the volts, for that one. 6. And we want the current, that is the question. So current is volts over resistance. That gives us 6 over 12. And that gives you what? 6 divided by 12. Yes, 0.5 amperes. Okay, so if we see here, this reading on here was 5 amperes. We know now that 3 amperes goes through there and 0.5 amperes goes through there. Goed, fancy. Without doing any further calculations, what is the current that passes through the last branch? Say again? You don't listen to our dear, please. Okay. Princess, good Princess, we have 5 people. Let's say these 5. This is your up. Needs to go through 3 subjects. These 3, take the easiest subject, go. Last in the first branch. Then half a person, we break job in half. She goes into the 6-6. What current goes through the last branch? Joanna? 1.5. So you're going to write here the current through the 4 ohm resistor will be 5 minus 3 minus 0.5. Gives you 1.5 amperes. I'm going to repeat that again. So the total current there splits up there, and there. The total current was 5 and it splits up. Some goes there, some goes there, some goes there. So you must see that this total current splits up into 3 parts. Are you making notes? Are you highlighting? I know this.
We also know it, not like
Hey, oh,
All right. We'll see. We'll see. Okay. Okay, next one. So now we have another circuit. Before we start reading a question, you're going to take your highlighters and you're going to consider. There you see the little men walks. This is the positive side. This is the negative side. So they walk from the positive. And they walk with 12 sandwiches. Okay, so there's the 12 sandwiches. Now they walk. Da, 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 da. Then they get here. The whole current must pass through there. All of the little men. So I'm making a note for myself. I'm saying that is the total current that passes through the 4 ohm resistor. Then they get to the parallel combination and they have a choice. They can either go through the 3 ohm resistor or they can go through the 6 ohm resistor. So they will split up the current. Tiamo, why will the current not go through the voltmeter? Why is it impossible to go through Miss Fushia? Because the voltmeter is Miss Fushia. She checks how many sandwiches you have before and after. Page back to the first page, last bullet. Yes, it is so high that the charges can try to go through there, but they'll turn around. They cannot pass through a voltmeter. Okay, so the current splits up in 2 there, and they get together here again, and you see the total current passes through that ammeter. So the total current passes through there. Okay, Tulwana. The resistance is 3 ohms and 6 ohms. Where do you think the biggest current will go? Through the 3 ohm or the 6 ohm, and why? Current. Where will the biggest current go? Through the 3 or through the 6, and why?
The 3.
Why?
Because it's the smallest.
Smallest what? Yeah, I'm going to move you until the back. Far. Because you're bothering me. So say again, Tawana.
I said it will go through 3
Why?
because it's the smallest.
Smallest, it starts with an R. Smallest? Resistance. Because it's the smallest resistance, most of the charge will go through there because it's easier. And the least amount will go through the 6 ohm resistor. Okay. Then you see you have 12 sandwiches. When you plan for the day, you're going to split the sandwiches into 2. Some will go to the 4 ohm resistor, and some will go to the parallel combination. We must remember that resistors in parallel will have the same volts. Those that choose math lit and those that choose math will have the same number of sandwiches. It doesn't matter which one you choose, you'll have the same one. Okay, right. So they asked that question 1, and so we're going to just divide our page into 2 here. Okay, for the first one they asked, calculate the reading on the ammeter in the circuit, and we saw that the ammeter measures the total current, so they are basically asking you to calculate the total current. For that, you need the total resistance and the total volts. Mama, what is the total volts for the circuit? 12. What is the total resistance? Can I just add them together? 4 plus 6 plus 3, 13. Can I do that? No, because these two are in parallel. I first need to do that whole weird thingy 1 over R parallel. So because they are in parallel, I cannot just add them together. Okay? So we're first going to say, let's look at 1 over R parallel. There's 2 things in parallel. 1, 2. So we're going to say 1 over 3 plus 1 over 6. So we're going to have two things there. Then when you get there, you get 3 over 6. And then the important step, now you must swap them around. So now you say R parallel is 6 over 3. So you must write that R parallel. You can't just say equal to. And that is equal to 2 ohms. Kumo, how do you know, or how do you think you're more or less on the correct path with that 2 ohms? It's smaller than the smallest resistance. Is 3 smaller than, 2 smaller than 3? Yes, it is. So I think I'm on the right path. Okay, so you can write there for yourself. That is smaller than 3, so you think you are sharp. Okay, so what we calculated there is the total resistance in parallel. But not the total resistance in the entire circuit, because there is another resistance. So we just calculated here the total resistance in parallel. But because this is next to it, it is in series with one another, we have to add that to the 2 to get the total resistance of the circuit. So we're going to say, right, the total resistance is thus 2 plus 4, and that gives you 6 ohm. So that 2 comes from there. Okay, so now we know the total resistance is 6. So I wrote down a 6 there. And now we're going to start calculate the current. So we have resistance is volts over current. The resistance we calculated to be 6. The volts is 12. And the current we want to get. Again, what can you, current is at the bottom. We don't like it at the bottom. We want it at the top. Now, like Bongani did, we can just swap them around. Or, there's another way. You can, this is the same as saying 6 over 1 is equal to 12 over I. So you can just cross them. Ne? So that's one way. So you can say I is 12 over 6. Or another way that you can write is I times 6 equals 12. And then you can say from there I is 12 over 6. Okay, so there's a lot of ways in which you can do this. Okay. Princess, 12 over 6 gives us? Yeah, 12 divided by 6. Thank you. 2 what? Ampere. Okay, so we can look at our diagram and see the reading there at the ammeter will be 2 amperes. So that is the total current. And because we said the total current goes through this thing, we can say that reading will also be 2 amperes. Okay, now they ask you at question 2, calculate the voltmeter reading V1 and V2. So they want to know, of the 12 sandwiches, how many go through to the 4 ohm resistor and how many go to the parallel combination. Alright, so let's take V1 reading first. You want to calculate V1. Okay, volts, resistance, current. We want to get the voltmeter reading. Tiago, jy moet skryf. Okay, so we want to get that voltmeter reading there. It is over the 4 ohm resistor. So that resistance there will be 4 ohms. And the current that passes through there is 2 amperes. So that there is 2. Okay, so we write resistance is volts over current. The resistance is 4. We want the volts and the current is 2. How do we get that 2 away from the volts? Yes. Then we get the volts is 8 volts. Okay, so that means from the 12 volts that we had, the 12 sandwiches, 8 goes to V1. Without doing any more calculations, Jabu, how many goes to V2? We had 12 sandwiches, 8 of it goes to V1. How many goes to V2? Yeah. Yes. So the reading on V2 will be 12 minus 8, and that gives you 4 volts. Okay. Then I ask you at question 3. Calculate the current in the 6 and the 3 ohm resistor. So they want to know, of the 2 amperes there, how many goes through the 3 and how many goes through the 6. Okay, so let's first look at the 3 ohm resistor. So we tell ourselves we're going to look at the 3 ohm resistor. We want the current, volts, resistance. The resistance of the 3 ohm resistor is 3. And we just calculated that of the 12 volts, 4 goes to the parallel resistance. So here you have 4 and here you have 4. Because the volts are the same in parallel. Okay, so this volts here is 4. Okay, so we have resistance is volts over current. The volts is 4. We want the current. The resistance is 3. Again, current is at the bottom. We do not like it there. We want to get to at the top. Okay, so we're going to swap or cross or whatever you want to do to get it there. So we have I is 4 over 3. And that gives you 1.33333333 amperes. Tamara, does it make sense that of the 2 amperes, the biggest part, 1.333, goes to the 3 ohm resistor? Why do you say no?
Oh, I guess it doesn't.
Why?
Because that answer is smaller to the...
No, we're not there. That is here. We calculate resistance. You want to call someone? Who are you calling? The freeway? Why does it make sense that the biggest part of the current of the 2 amperes, 1.33, goes to the smallest resistance? So, the biggest current goes through. Good. Then, Bongani, back to you. Without doing any big calculation like this, what is the current that goes through the 6 ohm resistor? Yes, Bongani. Nia, we just did it. Nia, here you had 2 amperes coming through there. 1.3333 goes there. How much goes through there?
1.6.
You don't listen to Bongani. If you want to eavesdrop, you must do it well.
I'm going to calculate it.
What are you going to calculate? What are you going to type in your calculator?
I'm going to type 6 over 3.
Okay? No. I don't want you to do that because you've typed in the wrong values. And I'm going to say this again. You have 2 men that goes through there. 1.33 goes through there. So of the 2, 1.33 goes there. How much is left to go through there? Nee, Bongani, I can see your head is not here today. You're on weekend already. You have 2 minus 1.33. That is 0.67 amperes. Okay, now there is another way which you can calculate it using ratios. Okay, now ratios are a bit more difficult, but sometimes that will be your only option. Okay, so how ratios work is when you get 2 resistance in parallel, you say my ratio is 3 to 6. Okay, because there's 3 and there's 6. Then you add them together. You say when I add them together I get 9. So I have 3 over 9 and 6 over 9. So 3 over 9 and 6 over 9. Okay, so that of the total current times the total current, we calculated it to be 2 amperes. Okay, so that of 2, so that is where I get that 2 from, times 2. Then for the first one you get 0.67 and the last one you get 1.33 amperes and amperes. Okay, so not too difficult yet. Okay, because are you going to say that 0.67 goes through the 3 ohm resistor? Look, we had a 3 and a 6. Are you going to say that 0.67 goes through the 3 ohm resistor? Why not? Because what Sepu, you were busy mumbling. What did you say? Because you were speaking just now. Because why? The smallest current goes through the bigger resistance, and the biggest current goes through the smallest resistance. So when you do ratios like that, you must know you must swap each other. So you're going to say that is equal to the current through the 6, and that is equal to the current through the 3. Okay, so what I want you to write down there, I want you to write that resistance is inversely proportional to the current. Do you remember that inversely proportional? So the bigger the resistance gives you the smaller the current. The one goes up, the other one goes down. Inversely proportional to one another. Okay, let's do some proper calculations. Okay, you guys are frowning like it's the hardest thing in the world to do this. Okay, so in your worksheet number 1, and you're going to do this in your writing book. Who needs paper? Who does not have their writing book here? Okay, please write this in your writing book more. So what are you at? Yes, yes, yes. Okay. So you had to do for homework, I think the other day you had to